Meet the AD6676, an IF digitizer for signals in the 70 to 450 MHz range, supporting bandwidths up to 160 MHz. Let's do a quick overview of this unique device before we take it out for a spin. The AD6676 contains 5 main blocks. The 50 ohm input attenuator is programmable in 1 dB steps up to 27 dB. The bandpass delta sigma ADC has widely programmable center frequency, bandwidth, and full scale. The ADC's clock can be supplied externally or, for frequencies above 2.94 GHz, generated by the on-chip synthesizer. The digital block mixes the ADC's output to baseband and decimates the data before passing the resulting 16-bit IQ words out the JESD 204B serial interface. Now for the test drive. Suppose that we want to digitize signals in the 108 to 118 MHz avionics band that lies just above the FM broadcast band. For this narrowband application, I'll use a clock rate of 2.4 GHz, an IF of 113 MHz, and an attenuation of 6 dB so that a full-scale input is now plus 2 dBm or a 400 millivolts peak. In this mode, the integrated in-band noise is minus 91 dBFS, which translates to an exceptionally low noise spectral density of minus 161 dBFS per Hertz. Now, let's see how the part copes with a big blocker at 105 MHz. As you can see, even though the blocker is within a dB of full scale, the in-band spectrum is remarkably clean. The largest spur is below minus 112 dBFS, and the noise density degrades by less than 2 dB. Having witnessed the high dynamic range in narrowband operation, let's push the bandwidth out to 160 MHz at an IF of 350 MHz while clocking at 3.2 GHz. I'll also zero the attenuation and drop the ADC's full scale to minus 10 dBm so that a full scale input is now a mere 100 millivolts peak. Even though the bandwidth is maxed out and the full scale is small, the in-band noise is minus 65 dBFS, equivalent to an 11-bit converter. Putting in a near full-scale signal at 370 MHz, we see a signal-to-noise ratio of 62 dB and a peak spur of minus 85 dBFS. I hope you enjoyed this brief overview and demonstration. Check out analog.com/AD6676 to see how you can best take advantage of this remarkable product in your next receiver design.